Bismillahirrahmanirrahim. Today we will start a new lecture series for the course Object Oriented Software Engineering. And the first lecture we are having today is Object Oriented Programming Paradigm Basic Principles. Basic concepts which are very important in the beginning so that we have a good understanding of object oriented principles, so that later on when we apply those things and we learn the advanced concepts, so there we must have a good understanding of these things. So we'll start our presentation, and as you see, the topic is object oriented programming paradigm, a basic introduction. And whenever we compare the object oriented programming paradigm, we always compare it with the structural paradigm or the procedural paradigm. As you know, earlier on, the programming development, program construction, software development was basically based on a structural approach, a software development life cycle, and basically it was called procedural paradigm. And why we call it procedural paradigm? Because there we have that understanding that software is organized around the notion of procedures, and sometimes we call it procedures when we also call it modules as well. So in a procedural paradigm, we are basically based on the basic concept of a module or a procedure, and what we do is we can further move on to develop hierarchies among those procedures, or you can say the modules or modular hierarchy. So in that manner we didn't have the concept of object as such, and there we are more interested in those functions or a functional, you can say, the requirements which can be transformed into a procedures or a set of codes. And how we add data abstractions into it, because we group together the pieces of data that describe the same entity. Helps reduce the system complexity as well, and it is a good way of maintaining records and structure. So therefore still the procedural paradigm is being used for managing data as well in database approaches. But as far as programming is concerned, there is a big shift towards object oriented paradigm. In contrast to the procedural paradigm, in object oriented paradigm, the basic building block is an object. So everything revolves around the object. Organizing procedural abstraction in the context of data abstractions. So approach to the solution of problems in which all computations are performed in the context of objects. Therefore, I say that objects is a basic building block, and we look forward and we will see that how we can identify those objects, their behaviors, their states, what functions they can do, and how we can identify those objects and we can define those objects. And whenever we talk about objects in an object oriented paradigm, we always see these objects as instances of the classes, because the objects are itself data abstractions. And when we talk about classes, so there we want to find out the similarities among those objects, and then we decide how to classify these objects. So later on we will see that what are the traditional classical approaches or the modern approaches we have to develop classes. And we can see some examples as well regarding this. So that is the difference between the object oriented paradigm and the procedural paradigm. So in object oriented paradigm, we are more concerned towards the object definitions, because the methods, the functionalities, or the operations are part of those objects. So as far as reusability is concerned, as far as maintenance is concerned, the object oriented paradigm has far more advantages over the procedural paradigm. So in object oriented paradigm, so some of these concepts which are very you can say the basic concepts, but we have to be very much clear about those concepts related to object, class, abstraction, polymorphism, encapsulation, and inheritance. So we will cover all these aspects in the later lectures in very much detail, but here these concepts need to be understood. So object, what object is? We can say a chunk of structured data in a running software system has certain properties. As you can see one of the example on the screen, and there you can see that there are certain objects such as Jane, Margaret. They have certain attributes which you can see as date of birth, address, position, which might be important in a given problem, in a given domain. You can see the information regarding account, saving account. There is information regarding transactions. So all these are basically objects, and whenever we talk about an object, it means that it has certain properties, and normally those properties are represented in terms of attributes. And when we talk about a state, yes, object has a particular state. So how you represent those states? So the values related to those attributes or properties basically reflects the state of the object, and we can further see later on that object exists in various states, and when object exists in various states, object can perform certain task in a certain state. For example, if we take an example of an ATM machine, so ATM machine has certain states. So when we go for a use into that facility where we have an ATM, so ATM is in the ideal position. So where we have some certain messages or there are certain recordings. So what happens whenever we insert our card into a machine, it means that event has been generated, and then the machine will find out or to validate that card or the user, and therefore, and you can say that the state might change. So it means a certain object can perform certain task in a particular state. So object has states as well. Object has behavior as well, because when we talk about an object, it acts and reacts. You talk about an order in an order delivery system or inventory system. So order itself is an object, but what we can do with that order can be created, that order can be cancelled, that order can be altered, so on and so forth. So object has a certain behavior. Account, if there is an account which is for example is considered as an object, so that account has to be opened, and that account has to be created, that account can be merged, that account can be closed. So certain actions which are also relevant with those objects. And obviously when we talk about actions, it means the reactions as well, because object has to act, because whenever we talk about an object oriented paradigm where we do not have that concept that the object lives in isolation. So object does not live in isolation. So objects interacts. So for example, in an account system, Jane is an account holder, that Jane is an account holder, and that Jane performs a certain activity in his account. So it means that these two objects are interrelated as well. So object obviously acts and reacts based on certain events, and later on we will see that how we can define those events and how that events basically create those transitions. So that will be covered in a state transition models later on, but that is the basic concept of an object. So we can say that object has a structured data that has a properties, it represents a certain state, has a behavior, it acts and reacts, may simulate the behavior of an object in the real world. So with this we can move on further and we can develop the definition of a class, because we normally represent a class as the representation of similar objects, although the concept of similar object looks very simple, but it is not that simple, because how to determine similarities among objects, it is a very difficult task in various domains. For examples, how we can distinguish various patients with respect to various diseases they have. For example, how we can distinguish various plants. So it has a certain domain information into it, which is a plant taxonomy. So we need to have that domain knowledge. So therefore we can easily differentiate among those objects. So objects can be differentiated in many manners. Objects are not only can be grouped on the visible characteristics. So there are certain behaviors which we have to see that what has that relevance among the domain in which we are dealing that problem, or we are modeling the situation. But for the beginners, yes, we can say that it has class has the similar objects which has certain instances. So we can say there are instances of a class. For example, in a university system there are students, so student itself can be categorized as a class, and there are certain objects who are the students representing various IDs. Those are the instances of those objects. So similarly, you can see one example here about an account. So account is one thing which can be represented in a banking system as a class. So if it is a class, so there are various accounts which will be there. So account is represented in terms of various attributes you can see, and the various methods which are being associated. So one thing which are the attributes, which are the similar, which are the properties, and there are certain behaviors or functions which are associated with the account. You can see in this example as well that account has deposit, you can get amount, you can withdraw amount, there is a limit, set limit, so on and so forth. So there are various functions which might be associated with this class. So there cannot be a generic definition of a class. For example, if I say account has a generic definition. No, because in every domain we have to model our situation, we have to model the real world. So wherever we model the real world, there we will see that what attributes and the methods which are relevant that can be included into a model. Later we can see how we can model a certain situation. So we can say a class is a kind of a software module, describes its instances, structures which are properties, and also contains methods to implement their behavior. And now there are certain questions which comes into our mind, that while we are modeling various situations, how we can develop a class. So what are the benchmarks? Because having said that earlier on, that the similar properties of an object can be identified and can be represented in a class. But a question might come from your side, that what is the way, what are the methods which we might use for class design. So remember, the classification itself is a very classical concept, because we are always dealing in classes. So even if there is a concept of class in this object oriented programming paradigm, but if you go back to the centuries, humans were also making classes to identify various things. The concept of classes is everywhere. We have a classification in plants, we have a classification in animals, we have a classification as well as in social dimension as well. So why we do this? Because it is easier for us to understand the concept. So rather than looking into the individual objects, it is good to have a class definition, and therefore it is easier for us to understand that how that object will behave. So there are three methods, quickly we'll go on. One is called the classical categorization, is the classical approach to categorize, and there the more focus is towards the given properties of the objects, and mostly there we are interested in the visible properties of the objects, which can be easily identified, which can be easily observable, and which can easily differentiate one object from the object from the other object. For example, if I show you a picture of a table and a picture of a chair, you can quickly identify that is a chair, that is a table. So you can easily differentiate among the two. How? Because the visible features can easily identify that this is the difference between these two, and you can identify those objects. Or for example, if I put a certain example of an animal and compare it with the other example of another category of the animals, you can easily identify, because based on the physical features which are already being identified. So it is easier for us to identify those features in terms of colors, in terms of size, in terms of dimensions, in terms of materials, so on and so forth. So that is the basic way of categorizing things, and that is being used in various other domains as well. The second concept is based on conceptual clustering, which is a very important and interesting concept, because here we cannot easily identify on the basis of the given properties. So there we look for a certain hierarchies of the classes, and we can go with either the top down approach or a bottom up manners, and we can divide things, and then we can come out with the definition of the classes. Example of a chair is a very interesting example, and that example is being quoted in certain books as well as a case study, that chair has many dimensions. So what type of chair you are asking about? Let's suppose if I ask you to develop a class for a chair, that chair might be a chair which I use in my office. A chair might be a chair with a desk in the classrooms, or a chair which is being used in labs, or a chair which is used by a doctor, for example, in dentistry, dental chair. For example, a chair might be a wheelchair which has a certain purpose, and chair might be a chair which is being used by a barber, or an electric chair, so on and so forth. There's so many examples of a chair. How you can identify such a thing? So it is not that easy to just to identify this with the help of classical categorization. So it is better to come out with the addition of concepts which are related to it, and these concepts will help you to make the hierarchy. So this is these type of chairs, then these type of chairs are further classified into these chairs, so on and so forth. In that manner you can cover almost all kinds of chairs. Another concept which is very much related to our computer science approach, and that is called prototype theory, which is based on the idea of necessary and sufficient conditions is almost never met in categories of naturally occurring things. Means that rather than pure classical categorization or a conceptual clustering approach, it is better to develop your own definition. So what you want to have in your prototype, define it, and then look for a certain object, that whether that object fulfills that criteria or not. So if it fulfills the particular criteria, it means that it follows the prototype theory. So you have a prototype definition of your class, which includes obviously the certain properties, attributes, as well as the methods you want to associate with that. So that is a good concept to develop those classes. So for all those students who are in their beginning phases and looking forward to have a better design, so they can use these approaches as well for classification. Why object oriented? What is a model and why? This is very important to understand. Why we make a model? We talk about a class model. Later on we will see more examples of class models, and we will also cover this in a separate lecture as well. But whenever we make a model, what is the purpose of making a model? So that you have to understand. A model is what? Is a simplification of reality. So what we want to do is we want to capture that reality in the manner it looks easier for us. So it can simplify things. So a model, you can say, is a simplification of the reality. For example, if you are looking forward to build a building, so how you conceive that building. So it is very difficult for everyone to conceive that building, even for designers as well. So it is good to have to develop certain models and view whatever you want to perceive about that building, which is coming into the reality later on. So model really helps you. A miniature of a bridge for a real bridge to be built. So rather than whenever we are building such products, so we can build a model and we can see. We can build a smaller physical model as well, and we can either go for simulations, and we can develop a 3D model or such kind of a model in any software simulated environment, and we can see that how it will look like, how it will work. A model is our simplification of our perception of reality, because believe me this thing, that whenever you are building such models, so obviously this is your perception. So the other individual might have a different perception. That is why in object oriented designs, when we give problems to our students to design it, so different students might come out with different designs. They might have different definitions of classes. So you will might find out that there are different behaviors that they have grouped together. So it means that is their realization, that is their perception of reality. That is important to develop it, because whenever we are developing these models, these are really helpful for us to communicate and to have clarification and to represent your perception of reality, because we cannot create a real situation whenever we are building such things. A model is an abstraction of something from the purpose of understanding, be it the problem or a solution. So we are looking for a solution, and obviously when we are modeling such certain aspects, so we go through with the process of abstraction, because whenever we transform the real environment into a model, we want to have a certain things which may be represented in the model, and we want to exclude things which we think are not necessary whenever we are describing that model. So therefore it is called the simplification as well. So it gives you a good understanding. So that is the basic concept which we need to understand. And in object oriented, we are also focused on developing these models. So how to differentiate between class versus instances? In the beginning, the students, whenever they are dealing with such case studies, they feel sometimes it is difficult to understand what is the instance, what is the class, how to differentiate between an object, how to differentiate between a class. So something should be a class if it could have instances. This is the simple thing which you have to consider. For example, if I pick up a certain student, his name, or a certain patient, his name, that is an instance. Obviously that is not a class. Something should be an instance if it is clearly a single member of the set defined by a class. For example, a film is a class, and what are the instances? Are the individual films. And obviously when you talk about individual films, so you may consider some of the attributes, some of the behaviors which are related to film. The reel of film is a class. Instances are the physical reels which need to be stored. So how those physical reels need to be stored, that includes certain attributes as well. Similarly, we have a science fiction instance of the class genre. Science fiction film is a class. Instance include Star Wars, so on and so forth. So these are some of the examples, and you can easily understand when you have certain objects given in a particular domain. So variable versus object, this is one concept which we need to understand. A variable refers to an object that may refer different objects at different points in time. So please differentiate between these two. Variable is something which you need to refer an object. So whenever we have that model and we want to refer a particular object, we need to define a variable. So an object can be referred to by several different variables at the same time. Yes, it is possible. So in a given program, how you deal with different variables, obviously it depends on how they deal with the objects. The type of the variable determines which classes of objects it may contain. A class variable value is shared by all instances of a class. Of course, that is called the basic definition of a static variable. It means that if one instance set the value of a class variable, obviously the all other instances should see the same change values. For example, if we have the value which is related to for example a price of a certain item, that has to be changed. So if that value is changed, that value is observable to all other instances as well, not to a single instance. So that is basically the concept of the variables and the object. So how to we can further see in the next lecture. So method, a procedural abstraction used to implement the behavior of a class. So we talked about various behaviors of an account, for example, opening of an account, closing of an account. So how, or for example, the account is, for example, blocked. So if account can be blocked, how, when account can be blocked? So it has a certain behavior which is blocked. Maybe the account is blocked whenever you do not have a transaction for the 6 month. So if you have this thing you want to implement there in your account class, so you need to represent this with the procedural abstraction for the implementation of that behavior. So it means that time period will be counted, and then after that it immediately calls that function, that behavior, and that will be implemented. So methods are basically the reflections which are there in the class definition. So several different classes can have method with the same name. Yes, this is possible. They implement the same abstract operation in ways suitable to each class, and that concept is also related to polymorphism, and that is very important principle and one of the strength of the object oriented model. For example, there are various kinds of employees, and we want to calculate salaries and calculate pay, but the function is same, but it may be implemented in different manner and for different kinds of employees. For example, there may be the hourly wages employees, there are full-time employees, there are part-time employees. So how that these calculations can be done. So that is something which is also the concept which is related to object oriented. So data abstraction is one thing which we need to understand, and what is that? Data abstraction is the object oriented programming, is a percept that allows programmers to symbolize the relevant information of data at the same time as hiding the complicated implementation info. So what data abstraction does is a simple process in which what we do is we keep that data which is relevant or pertinent to a particular object. We only keep those behaviors which are relevant or important in a particular domain for a particular object, and what we do is we exclude all other properties and behaviors. This process itself is called an abstraction. For example, if I have a definition of a patient in a hospital system, so there what information I want to have regarding patient, for example, that patient is inpatient or an outpatient. So if it is an outpatient, what information we want to keep regarding that particular object. So that is something which is called the process of an abstraction, because in a real life situation or in a real domain, there are lots of things which are relevant, which are there, but it is not important to capture all these things into our model. So what is relevant, that has to be come into the model, and that is the concept of data abstraction, which we also perform whenever we are modeling certain things. It permits the introduction of summary information sorts that may be used to model actual entities in the software gadget. So that is the concept of data abstraction, and with this we'll move forward. Data abstraction and then polymorphism, which we have discussed earlier on as well. The property of object oriented software by which an abstract operation may be performed in different ways in different classes requires that there be multiple methods of the same name. So there is the same name, but there are multiple methods. For example, just talked about calculate pay, or calculate area, or calculate interest. So the operation is same, but may be performed in a different manner. The choice of which one to execute depends on the object that is in a variable, reduces the need for programmers to code many if else or switch statements. So this gives great benefit to the developers, that there is no need to develop many situations as we do in the procedural paradigm. So this is again something which is not there in the procedural paradigm, where we go for structure statements or if else statements to cover various aspects. So there we can easily implement this. So that is one concept which is also important and relevant, which is related to object oriented paradigm. And the last concept which we want to discuss is about inheritance, which should be very much clear, because whenever we talk about relationships among objects or among classes, we need to know that there are certain types of relationship which exist among those objects and classes, which is one of those is called inheritance, which is one of the core principle of the object oriented paradigm. And whenever we talk about inheritance, it means we talk about superclasses or subclasses. And whenever we talk about superclasses, it means that it has certain attributes or behaviors which may be which should be followed by all subclasses, or they inherit all those attributes and behaviors of their superclasses, as well as all those relationships which that superclass has. Although the subclasses might have their own relationships, and subclasses might have their own further specializations. So that is also called gen-spec structure or generalization specialization as well. So instance hierarchies shows the relationship among superclasses, and inheritance is what the implicit possession by the all subclasses or features defined in the superclass. And there is one definition here, or one example here, which you can see that we have an account class which we have discussed earlier on, but that account might have different kinds of other types of accounts, which include saving account, checking account, and mortgage account. So the account has the basic definition which is there in the super type, but there are certain behaviors which are related to checking account or a mortgage account or a saving account, which are specialized in nature, and therefore it can be defined in a specialized classes. So that develop not only the hierarchy, but it later on we will see that it can also develop a lattice, means there are subclasses, there are child classes, and the child classes have further child classes, and there we have further complex concepts such as multiple inheritance. So with this I conclude this introductory part, and I hope that you have a good understanding of the lecture, and we are looking forward to have other lectures soon, and please give your feedback. Thank you so much. Thank you so much, and I look forward to have further discussions and further lectures. Thank you.